Hi, my name is David Wyban, an applications engineer here at Keithley Instruments. Today I'm going to show you the trace mode of Keithley's parametric curve tracer. Trace mode is designed for quick and easy IV characterization of power devices and has an interface similar to that of a traditional curve tracer. Inside the Model 8010 test fixture, I have two devices that I'm going to use for this demonstration. In the high current side, I have a power MOSFET device rated for up to 20 amps of continuous current. In the high voltage side, I have an IGBT device rated for 2500 volts. In this demonstration, I will use trace mode to quickly gather the family of curves on the MOSFET device and use it to find the breakdown voltage on the IGBT device. Here is the trace mode interface of the parametric curve tracer. Just like on a traditional curve tracer, there are controls to set up the step source, a graph to view the collected data, and a sweep slider to adjust the output level, similar to the knob found on a traditional curve tracer. One benefit of trace mode over a traditional curve tracer is that trace mode has device libraries that set up the test for you. To test a new device, you simply select the device type from the device drop-down, and then you select the test type from the test drop-down. Right now I have trace mode configured to gather the classic family of curves on a MOSFET device. To start testing, simply click the Run arrow. The test begins to run and the graph is updated as the data is collected. To sweep to a higher voltage, simply drag the slider to the right. You can see on the graph that the voltage on the curves sweep higher as I move the slider right. To reduce the sweep voltage, simply drag the slider to the left. Alternatively, you can use the arrow keys on the keyboard or the scroll wheel on the mouse as well. To stop the test, simply click the Stop button. Unlike a traditional curve tracer, the data collected can be viewed in a tabular format directly on the screen. Saving the data to the PC is as simple as right-clicking the datasheet and selecting Export. I now have trace mode set up to perform high-voltage testing up to 3000 volts on the IGBT device. Again, I click the Run arrow to start testing, and the live results appear on the graph. This device is rated for 2500 volts, so current remains low for voltages below this level. As I increase the voltage past 2500 volts, I reach a certain point where the current rapidly increases, indicating that the device is broken down. Looking at the graph, you can quickly see that the breakdown occurs at approximately 2700 volts for this device. This demonstration should have given you a good idea of how trace mode of the parametric curve tracer works. This mode is handy for quickly testing whether a device is good or bad, and is commonly used during device development and failure analysis. Users familiar with the traditional curve tracer will appreciate the familiar interface, and everyone can appreciate the simplicity. If you would like more information on the parametric curve tracer, please visit us online at www.keithley.com. Thanks for watching.